Have you ever wondered how parts fit together perfectly? Mechanical engineers use something called fits to make sure this happens. Fits are crucial in designing everything from cars to rockets. They determine how tightly or loosely parts join together. Understanding fits is essential for building safe and reliable machines. In engineering, fit describes the relationship between two parts designed to fit together. It refers to the amount of looseness or tightness between these parts. This relationship is determined by the difference in their sizes. Fits matter because they directly impact how well a machine works, its durability and its safety. Clearance fits allow for space between two parts even when they are assembled. This intentional gap is crucial in mechanical engineering, ensuring that parts can move without interference. This space allows for movement like rotation or sliding. Without this clearance, parts would grind against each other, leading to increased wear and potential failure. A good example is a bearing and shaft. The bearing must fit around the shaft with just enough space to move smoothly. The bearing needs to rotate freely around the shaft. This freedom of movement is what allows machinery to function efficiently and reliably. Clearance fits are essential for reducing friction and wear between moving parts. By minimizing contact, they help extend the lifespan of components and ensure smoother operation. They also allow for thermal expansion and make manufacturing easier. This adaptability is vital in environments where temperature changes can cause materials to expand or contract. Section 4. Interference fits, holding things together tight. Interference fits, also known as force fits or shrink fits, occur when the assembled parts are intentionally made to overlap in size. This overlap creates a situation where the parts must be forced together, often using specialized tools or machinery to achieve the desired fit. This means the parts must be forced together, creating a tight fit that prevents movement. The process ensures that the parts are held together with significant pressure, which can be crucial in applications where precision and durability are paramount. A common example is a gear pressed onto a shaft. This method is widely used in various industries, from automotive to aerospace, where the reliability of the connection is critical. The pressure from the interference fit keeps the gear securely in place. This tight fit ensures that the gear does not slip or move, maintaining the integrity of the mechanical system. Interference fits are used when a strong, permanent connection is needed. They are essential in applications where the parts must withstand high loads and stresses without any risk of loosening or failure. This method of assembly is a testament to the precision and engineering required to create reliable and long-lasting mechanical connections. To Section 5. Choosing the right fit, clearance or interference. Choosing between a clearance and interference fit depends on the specific application. Consider these factors. Do the parts need to move relative to each other? This is a crucial question in determining the type of fit required. If yes, a clearance fit is necessary. Clearance fits allow for free movement between parts, reducing friction and wear. Is the connection intended to be permanent or easily disassembled? This consideration impacts maintenance and future modifications. Interference fits are often permanent. They create a tight bond that can withstand significant forces, making them ideal for high-stress applications. How much force or weight will the connection be subjected to? Interference fits are stronger and can handle greater loads and stresses. Engineers use standardized systems to specify fits in drawings. These standards ensure consistency and reliability in manufacturing. These systems use letters and numbers to represent different classes of fits. Each class defines the tolerance range for the fit. Understanding these systems ensures parts are manufactured to the correct tolerances. Precision is key in ensuring the parts function as intended. By carefully considering the needs of their design, engineers select the right fit to ensure optimal performance, safety, and longevity of their creations. This meticulous process involves evaluating the operational environment, material properties, and the specific requirements of the application. Additionally, engineers must consider the potential for thermal expansion and contraction, which can affect the fit over time. Proper fit selection can prevent mechanical failures and extend the lifespan of the components. In summary, the choice between clearance and interference fits is a fundamental decision in mechanical design. It requires a deep understanding of the application's demands and the behavior of materials under various conditions. With the right fit, engineers can achieve designs that are not only functional, but also durable and efficient, ensuring the success of their projects and the satisfaction of their clients.